Our first speaker here is Kevin Boos. He's a tech lead at Project Robius, and he's currently the principal architect at Future Way. And I think I'll just hand it over.
Okay, thanks. I'm not the only one, but I am an architect. Okay. Right, so today I'm going to talk about some work that we've been doing over the past 2 to 5 years, depending on how you count it. This is kind of the combination of 2 separate projects, Makepad, which is a UI toolkit that if you've been to Rust Week before, you're undoubtedly familiar with, and Robius, which I introduced last year at Rust Week, which is a companion, you can sort of say, to a bunch of different Rust UI toolkits. So today's talk will be a little bit different than talks that I've given in the past, in that I will dive into the code and actually show you how to write something like a real Matrix chat client, which I'll use as my primary demo. So before we get to that, I'll bore you with some overviews and front matter. So what is Makepad? What is Robius? What is our goal here? The goal is that you as an application developer can have a single code base, just one repository, that only uses one language, Rust, with no bridges, and it seamlessly works immersively on many different platforms by allowing you to deeply integrate with the platform-provided APIs. So we can have lots of nice screenshots, everything from a synthesizer on the top left to my chat client on the bottom right, and a bunch of different views of the same apps on different platforms. So that's kind of a quick overview. Let's talk about the background and the motivating characteristics of each project. So at a glance, what is Makepad? It's a high-performance UI framework that's written entirely in Rust for Rust developers. So it offers a custom UI design domain-specific language, which allows you to do some nifty things like a mixed or hybrid intermediate plus retained mode. It has shader-based styling, which is kind of similar to what you've seen in Shader Toy, if you're familiar with that, with built-in live reload of that DSL. It's very lightweight, very efficient, as you may have seen in previous talks. You can compile the entire thing, or the Makepad Studio, which is their IDE project, in around 10 seconds on modern hardware. Mine is an M1 series MacBook, so maybe 18 to 20 seconds for me, but that's still pretty good for an entire framework. Supports all the platforms that you would expect, and very recently, within the past several months, we've been working on supporting OpenHarmony as well. So then what is Project Robius? So Makepad was the UI toolkit for drawing, getting integrating with basic things like touch events and other system things that are required for UI. Project Robius aims to fill in those gaps such that you could access everything else from the platform that you'd want to beyond just the UI. So that would be things like accessing current location, bringing up a biometric prompt, and anything in between, not just hardware, but also the platform abstractions, maybe accessing application-specific local or cache data directories, things like that. Our secondary goal here is to make mobile a first-class citizen in the Rust community. I believe previously, not that this is any judgment on the project, but I believe that mobile has sort of felt like a second-class citizen, and there wasn't a lot of crates and infrastructure targeting writing an application on mobile. And you'll see that I can demonstrate our applications on iOS and Android, and they work just the same as they do on desktop. And then kind of our underlying goal here is to bring 2 different groups together. One, we want to bring existing front-end developers over to the side of Rust, the dark side, and get them to use Rust and experience its benefits. And then we also want to allow existing Rust experts, all of our fellow Rustaceans here, to start actually developing applications in Rust, their beloved language. So I probably don't need to hammer home the points, but yes, the idea would be for developers to be able to leverage the robust and safe ecosystem that Rust has for high performance. They never have to deal with multiple languages or environments, no bridges, and you wouldn't have to write any sort of platform-specific code. So the 2 of these projects have been collaborating for the last couple of years, roughly, maybe slightly less, year and a half. Makepad itself has been under active development for over 5 years now, and today they just released their version 1.0, so that's exciting. I'm using they because I'm not in the Makepad team, but I do make significant contributions to it. But like I said, there's a lot more that you need to create an immersive app that runs on all these platforms and leverages the platform API. So the need for this fostered our joint collaboration, which has been ongoing for roughly the last 2 years, maybe 18 months. So both of these projects are fully open source and decentralized, just like most of the projects you see here. and everything is written entirely in Rust for Rust developers. So in the case of Makepad, there's no underlying web engine. We're not doing something like Electron. We directly use the native platform APIs, and the same is true for all of these Robius crates that you'll see. Excuse me. So this is a little bit different than I think the traditional application development style, where you have maybe the core business logic written in Rust, and then you have an additional set of libraries, or rather additional set of components that wrap that, and those are written in whatever the platform native thing is, like Kotlin or Swift. So just a little bit more boilerplate before we get to the code. What are our goals? So number one, we want to achieve feature completeness across the entire stack of anything that can be considered under the umbrella of application development. So that means a full set of widgets, support for themes, internationalization, localization, all that good stuff. We're still quite a ways away from this. There's quite a lot left to do. We want to be able to offer the application developer access to deep system integration such that they can use platform features without any platform-specific code. And then we also want to allow them to easily build and package and publish those app bundles for the apps that they write using these tools. So I think that's pretty self-explanatory. In addition, we want to, eat our own dog food here. We want to create some apps using this framework and show that we can create beautiful, polished, and performant apps with nice code. And I'll show off, hopefully, a good example of that shortly. So here are some of the examples of apps that we've already written. So internally, Makepad has an IDE called Makepad Studio, which I briefly mentioned. That's for desktop. Today, I'll show off the Robrix, the matrix chat client called Robrix, which I've written, which runs on all the platforms. And then we have a variety of other projects. One particularly cool one is called Molly, which is sort of like LLM Studio, but in Rust. And it allows you to run local LLMs and cloud-based ones on your desktop platforms. So the main idea here, again, our top level goal, I guess you could say, is if we make a really good app, we make a really strong case for app dev in Rust, which benefits everyone in the community. Okay, so one of the things, I'll probably skip through these just to get to the code shortly, but one of the things we want to do is create a reference design for the full stack of system components required, needed to actually make one of these apps work. So of course we have the UI toolkit pictured, we have the concurrency management libraries, which we're working on, and the platform abstractions, which is kind of my main focus these days. And then all of these integrate nicely with the underlying platform. So for an app like Robrix, a relatively complicated matrix chat client and more, you can see there's a bunch of different components here that we need to develop and that need to work nicely with each other. So far, we have made Robrix sort of the driver for which things we prioritize implementing. So I've made a lot of contributions to Makepad in order to get it up to speed such that we can actually implement the various views and features you'll see in Robrix in a second. And the dog fooding has led to, I think, a nice path forward. So this is just one example. There can be many different structures for different applications, of course, but that's kind of the overall high-level diagram that we'd like to strive for. So all right, without further ado, let's get to some demos. I think I have to kill the slideshow to stop the mirroring. Okay, so, really? Oh, that's irritating. Sorry, let me unmirror again. Mirror. Okay, geez, I'm gonna have to do that every time. Okay. So this is Robrix. Robrix is a matrix chat client written 100% from scratch in Makepad and using Robius components. So when you first open, you get just a basic welcome screen. Now, this is my actual personal account, so hopefully there won't be anything bad that you guys see. But yeah, you can see you get nice performance scrolling. We have a variety of different unique widgets. You can style things as nicely as you like. I think one thing that I really enjoy about Robrix is that when using Rust and Makepad, we have the ability for high performance. So we can do things like render dozens of rooms, dozens of chat rooms simultaneously. And using this dockable API, we can get a nice side-by-side room view, which is always something that I've missed in other chat clients like Discord and things like that. I hope the scrolling comes through nicely, but we can easily hit 120 FPS, even with very demanding workloads and showing interesting dynamic or animated content as well. So let me just pick a few rooms and I can show you off the dock. and the resizability. So I can say, hi from Rust Week. And then we should see, oh, right, I've got to go to the bottom, right? Okay, so what we're able to do here is, just the same stuff that you would expect from every chat client, but in order to get there was a relatively tedious process. So this is roughly maybe a year and a half of development, primarily on the frameworks layer. So the idea is the next person to implement something like this would then only need maybe a few months. So hopefully that will come true for whoever decides to try out an app motivated by its talk. So another thing that I've mentioned a lot is the support for multiple platforms, right? So in order to do that, we need to have sort of an adaptive view that changes to your screen size. So let me show you. Hopefully this will, is that working? Okay, yeah. So when you get to a small enough point, we're now at a mobile view, which is what you would see on iOS. So I can bring up my iOS simulator. This is the exact same app. No platform-specific code, nothing particularly different between the two other than the view that's chosen. And you can see there's sort of a different type of interaction. And we're able to reuse widgets very nicely across the two. So let me just click on one here. And you can see I can give one example of something that's interesting in different platforms. So on a desktop platform like macOS here running natively, if I wanted to do some action like edit or reply to a message, I would right click. If I want to do the same thing on iOS or Android, of course you would long press. Right. So that sort of abstraction is there, and the underlying infrastructure to make that happen is part of what I'll show off today, in addition to the actual code for this application. So yeah, that's Robrix. That's what you can do with Makepad and Robius, and there are also some other things we can do. I can give you one quick example. It's not going to be massively impressive, but I can show off the location here. And okay, yeah, that was instant. So this is using the Robius location crate, which abstracts access to your geolocation APIs across all the different platforms. So with this on macOS, you do have to have an actually fully installed version. So this is one that I've installed, as you can see here, running as a properly installed native app. So I'll go ahead and send that, and then here we are. And with other Robius crates, you can get interaction with opening different default system applications, like your browser, or in this case, I'll go ahead and open Apple Maps. I've actually never done this before. Let's see what happens. Okay, there we go. So we have that deep platform integration that you would expect from something, as if you wrote this app in Swift, but it's purely in Rust. Is that the right location? Yeah, sure, we'll say it is. Okay, so right. That's Robrix in a nutshell. I think I've maybe spent too much time on that. Let's go back to the talk, and then I will get into some of the code. Ah, darn. What is the shortcut for restarting? Is it like Shift F5? That's what I get for using PowerPoint. Shift F5? Yes, okay. So there's quite a few implementation challenges in creating a framework that is capable of writing an app like this. Of course, there's a lot of unexciting UI features that we had to implement, things like the infinite scrolling list, just the ability to show overlays, tooltips, things like that, a lot of initial UI projects, they don't really want to focus on. So we had to get kind of this productivity business logic stuff out of the way. A major part of Robius and Makepad and every other project that is developing these UI toolkits spends a lot of time on exposing and abstracting the platform APIs and OS services, so that's sort of a given. Of course, we need to support complex multi-step builds that combine Rust. On Android, we might have Java. On Apple, we'll have Objective-C, and a bunch of different things that combine multiple pre- and post-compilation steps in order to actually create that application, which you then need to bundle, code sign, notarize, whatever it is, because a lot of this is required in order to access those platform abstractions on certain platforms. So geolocation, system notifications, as I mentioned, are things that require you to actually install a bundled app. And of course, we need to make all of this work nicely across completely wildly disparate platforms. We also focus very much on maintaining high performance in the face of high concurrency and asynchronicity. So in the case of a matrix chat client, there's lots of stuff going on in the background, and we have a lot of interesting challenges there. I don't think I will spend too much time on those today, but one of them is that a bunch of different things can either only run on the main thread or require an async API, so we need to run them in an async context, or neither, and we want to run them in the background on a native thread context. And there's a bunch of different ways that we need to communicate with these different execution contexts. So I won't really get into this today because I want to show off some code, but this is one of the major challenges that we face, especially using an application SDK like the Matrix Rust SDK, which generally forces you to use asynchronous code. Okay, so now let's get into something actually fun. Okay, quick water break. So every time I see a really neat Rust app being demoed, I always wonder how it looks underneath the hood. What does the internal code look like? So that's kind of my goal with this. The remainder of this talk is to go a little bit deeper than a visual demo and give you a feel for what the actual code looks like, and maybe kickstart your interest in writing a Makepad app. I will show off a few select components of things that you saw in Robrix already, and hopefully that will inspire you. I have some explicit non-goals as well. This is not going to be a comprehensive tutorial. You won't gain expertise on Rust, Makepad, or UI dev, so I can't help you there. And this won't necessarily be the best way to do things. However, if this does inspire you and you do want to dig deeper, we have gone to great effort to set up a really cool Makepad demo room, which will open today behind Cinema 11. At 3 o'clock, and it'll also be around all day tomorrow. And then Makepad has a workshop on Thursday. I'm not sure if that's open, but if you're already in attendance, lucky you. Okay, so here are some things that I'm going to show off today. Just the basic view and widget structure, how you define widgets, how you make them work together. I'll dig down a little bit into the platform-specific code for Makepad itself, specifically something I added recently, which was support for native gestures, i.e. a long press or a long click. And then I'll talk about how we can have interaction between different widgets, no matter where they are in the widget tree, in weird and different ways. And then I'll show off real quickly how we can do something like access the location in a platform-agnostic manner. Okay, so bear with me here for a second. Okay, great. You can still see it. All right, so let's start with something really simple. I had shown this. Does that work? Great. Okay. Let me go to a test room. Okay. I had shown this little location view. So let's just study this one, right? Really simple, this little light blue background view. This is, oh, okay. Can everybody read this text? Is this okay in the back? Good? I can't see you, so I'm just going to assume. Right, so this is very simple. It consists of just one line of text here, which is not changing. And then here, this is sort of, oh, that's blinding for me. Okay, great. Yeah, even better. So we have one line of text here at the bottom, and that corresponds to this. So this syntax here, I am going to, oh, here, I know what I can do. Excellent. Okay. So this corresponds to this label, and a label is just a plain view of unselectable text with a little bit of formatting. This is the Makepad DSL. Basically, this says instantiate a widget. It doesn't have a name. If we want to give it a name such that we can do something with it, for example, determine or handle an action or an event on that, we can give it a name like this, right? So you'll see I haven't given this one a name because I don't need to change it. It's just fixed text. This one here, I have given a name, and it starts with the default text of fetching the current location. And I have a little bit of formatting here. I want to move it, slightly to the right. So I have a little bit of left padding, and you can define all these things differently. And then I have two buttons side by side. So previously, the context of this view was that it had a downward flow, which means each thing will come successively beneath the one above it as you define more and more things. But what if I want to have two things next to each other? Of course, I need to change the flow to something like right, or I can also have right wrap, where it'll automatically wrap to the next line if the things become too wide. But in this case, I'm okay with that. And then I define a subview within this larger location preview. You can see my cursor, right? Okay, great. A smaller subview that contains these two buttons side by side. All right, so one is the cancel button, one is the send button. So that's basically just how you would define a simple view like this. Now you can get as abstract or as in place with the code as you want. In this case, I haven't done much special refactoring other than just taking this as a separate view and defining it here. I use, of course, unsurprisingly, a pub keyword, much like Rust, such that another view can include it as one of the constituent or child views within it. So in this case, I have an outer view, the room screen, which is including this view optionally. It's invisible by default, as you saw here. And when I press this button, there will be a series of actions that occur that set the visibility to true. So yeah, this is not particularly unique, but or interesting, but that kind of gives you just a very basic feel for what the DSL looks like. So the idea is here you're instantiating a view. If you want to connect it to a Rust structure, you use this syntax here, the double curly bracket, right? And then thanks to Rust Analyzer, we can jump to the definition. So this is basically just a simple wrapper around a view. And a view is just Makepad's very kind of basic default widget that contains any other number of arbitrary views. So then we have some data, some state that we want to keep within this particular view. Since it's a location preview, we care about things like the the coordinates that were retrieved from the platform and the timestamp. Perhaps maybe I wanted to show when you got that location so you could see if it was stale. Right? I'm not doing that in this view, but I could. And then, in order to handle events, I implement the aptly named handle event function. Which basically gives me the option to query the DSL, query the views and the widgets that I created in the DSL above with special commands. So actually, yeah, so here's one example of that, right? So here I'm querying the button called cancel location button, which is what I named this particular button, right? And then I'm wiping the state and hiding this view. So when I click cancel here, that's what triggers, because it'll be a series of mouse events that propagate throughout the system, and then we'll do a hit test on that buttons area, and a lot of this stuff is abstracted away for you, but you can handle this specific action within the code right here. And then I have a note that to actually handle the send location button being clicked, I can do that in a different widget. I don't have to do it here. I can do it anywhere else that I like. So in this case, it made a little bit more sense to do it in the higher level room screen view. So let me see, send location button. Yeah, so here's that code. Same sort of thing, where we're basically just doing a hit test hidden by this handy dandy clicked function, and then getting the current information and then submitting an asynchronous request such that a background task can go ahead and communicate with the Matrix SDK to send that current location as a room message. So I think that's relatively easy to follow. The idea here is that you can compose this and flatten it or structure it arbitrarily in any way that you want. You don't necessarily have to move things into a separate widget. As I showed here, it's actually probably the cleanest way to do that. But in this room screen, you'll notice this is many thousands of lines of code. So this is due for a refactoring in which we move more things into their own separate widget. But you don't need to do that. So it allows for, I think, relatively quick prototyping in that case. Okay. So that was just a very simple view. This particular view here. Can you? Okay. Right. Let me go back to the slides and we'll look at the next thing. Okay. So you notice that location preview pane was shown within the context of the larger context of a room screen, which is this particular view. So I'll give a little bit of a visual selection of each of the views and how we compose and nest them together. So this particular green outline box here is the entire room screen. You'll notice that it consists of a timeline, which is the list of messages, using the portal list widget. So that is the infinite scroll widget. And then we have a variety of different templates or other child widgets that can be displayed and added into the portal list. So we have a bunch of different things. We have a small state event, which is like somebody joined or left the room. We have a date divider, that's self-explanatory. We have a variety of different messages, things like the default message in red, which is text or an image message, or a condensed message, which is just the same thing without the profile information that you see here, right? And then we'll have things like reply previews, other sub-widgets within a message, your avatar username, and then of course the content itself, which is either richly formatted HTML content like we see up top, or just regular plain text. And then of course we also want to be able to show reactions here. And then it's kind of hard to see this example of a red marker to see to determine who has seen a particular message. And then at the bottom, the final thing that's included in the room screen is this input bar, which shows the location button that I previewed before, I demoed just now. A text input, which also allows for mentioning users, and then a send button. So this is how you would compose something like that. So if I were to show this off in a tree form, it would look something like this with a lot of things omitted just for the sake of brevity. And the things that I've shown so far are highlighted in blue here. I have shown some other things, but these are the ones that we focused on, so I'll get out of the way. Right, so the location preview, I can show everything because it's quite simple. It's just those things. And everything else this is how everything else fits in. So then the next question is, how do you interact between different widgets or from a background task to a widget? How do you propagate state changes in data throughout the system, right? So let's say, let me go back. Let's say I wanted to, when I click this send location button, I want to do a variety of different things. I want to actually send the location, but maybe I want to do some other thing like log a notification or save something to disk, right? For that, I can use what's called an action, right? So an action is a type of event, and I can show you this in the code, which is typically sent from widget to widget, and it propagates throughout the entire system. So let me start a new example with, let's actually start from the very lowest layer. How much time do I have left? 15 minutes? Okay. Let's start from the very lowest level of the long press, which you saw here, right? What happens when I physically press on something for a period of time? I get a gesture recognition event, which for iOS is handled here. So we've created a delegate. Let me see here. 5 minutes. Oh boy. Okay, I'm gonna have to move real quick. Okay, okay. So we'll go through this super fast. Basically, we define in Objective-C using the Objective-C syscrate a very simple delegate that waits for a gesture recognition state to occur, and then we send the long press up and we bubble it up to the rest of the Makepad layers, which eventually results in this long press event, right? So it's very simple, just the coordinates, the time, and in what window that occurred. And then if we want to actually handle this, as you may expect, we can go, So there's a big old enum of possible events, and within this there are several different things. The one that we're looking for now is long press, which is here. And then we can, do various hit testing on particular widgets to see if they were long pressed on. So in the interest of time, let me move back to the Robrix code. So we can search for long press. And in this case, this is the one that I want to see. So what I've done here is within the message widget, which is one of these, right? This itself is one condensed message. I'm doing a hit test to see if I've gotten a long press. If I do, I then go ahead and emit an action from that. And what that allows me to do is have this event, this action, be handled by a completely separate entity that has no relation to it in the widget tree. So again, what I'm doing here, just to clarify, I'm within a message widget here. You can see? Okay. I'm within a message widget here. I'm getting a hit test, and I am handling the long press event in order to emit an action. The action on the next event loop cycle gets propagated throughout the entire app, at which point any widget can handle it. So in this case, we want the top level widget app UI instance to handle it. Which looks like this, right? So if I right click, you can see I've put a kind of gray background over everything, and I have a highlighted content window that shows all the different actions you can take on that message, right? So if I click reply, another action will be sent back to the room screen that says the user selected reply, and then it will show this reply preview and focus on the keyboard, right? So in the interest of time, I am way behind time, so I apologize for that. But yeah, let's move on, or let me quickly show the way that the app handles this. So this is the top level app here. I am handling this by populating the message context menu here with show, and the contents are shown here. Right, you can see this basically does the whole thing where it determines which of the possible buttons, like for the various message actions, are visible and which ones are enabled. Right. When you click on one, I'm emitting that action again. And I am handling that back in the room screen, which I unfortunately ran out of time to show, which will then, perform whatever action you have, like showing the editing pane, showing the reply preview, or something like that. Okay. Well, I'm not going to have too much more time to do other cool stuff, but come see me or at the Makepad group, the Makepad booth for more information. So just real quickly, the current status of the project. As I said, most of the platforms are already there. Does it say 1 minute? Okay, geez. Most of the platforms are already well supported in both Makepad and Robius by our crates. We have OpenHarmony as a new target platform here, in which we only have basic support for things like drawing simple UI stuff and touch input. As I said, Makepad recently had its 1.0 release. Here's a screenshot of Makepad Studio, which is an IDE that you can use to develop these things and have nice integrated hot reloading and a bunch of other cool features. Generally, the widget set is there of all the fundamental widgets, so you can take it and use it now. There's still some progress to be made, but that's where Project Robius steps in. So we have a bunch of different platform abstractions that we're targeting. Currently, this is our... Yeah, there we go. This is sort of our state of the crates. Some of these have been added into Makepad. Some of these have been added or implemented as standalone crates, and we'll continue to improve upon them. And then one thing I want to do the rest of this year is to test them deeply with other UI toolkits like Dioxys, Xylem, or eGUI, any of these projects, Slint. So we all sort of collaborate behind the scenes, and I think this is a great example of that. So I've mentioned some of the other roadmap items already, but real quickly, we just want to go ahead and continue to expand the widget collection and the support for different types of input events, namely app life cycles, like pause and resume on Android or something, and get all of that working very nicely with your application. We'll continue to work on adding more of those platform features, some of them that you saw missing or highlighted in orange, including support for OpenHarmony. We want to improve build tooling continuously. We're using sort of a hybrid of our own tooling that Makepad has developed and Cargo Packager from the Tori community, and contributing to that as well. We want to publish these apps. I've published a release on GitHub for Robrix, so you can go and download that and try it out. But for iOS and other platforms that are a little bit more finicky and demanding, we'd like to publish that to the actual stores. And then, of course, documentation. So Makepad just released their 1.0, and they have some nice docs to accompany that, as well as sort of like a UI zoo example that shows all the different widgets that exist currently. So you can go check that out. All right, so I think the main takeaway I'd like to leave you with here is that I believe that we can actually use Makepad and Robius together to develop a complex real-world app, as you hopefully believed, based on my demo with Robrix. I think Makepad excels in enabling very high performance for demanding use cases, but maybe not so much in the case of a super simple quick start for a relatively simple, one-page app that just shows a text or something like that. We still have quite a few challenges to get through, but I do anticipate many, many improvements in the coming year as we continue to collaborate with other folks on various platforms and various key components that the whole community will use. And then I'll leave you with our blog here, which I've recently, at the beginning of this year, made a couple of posts to kind of lay out the status and what we did in the past year. So I'd like to acknowledge the help that we had from many different folks here, the Makepad team on the left, Robius folks working in the middle, and then on the right, several folks that have contributed to Robrix. And with that, I will take any questions. Thank you. And sorry I ran out of time. I wanted to show some other cool code examples, but it is what it is.
Well, yeah, so I think it was a fantastic presentation.
Thanks.
We're gone slightly over, so we still have time for 2 or 3 questions. So if you have a question, could you please come to the front of the room? I see someone's getting bullied into asking a question up there.
I have a question.
Yeah.
You showed an example where you did a query for one of the things in a view, one of the buttons. It used a macro, and I was wondering, is it like statically checking that button actually exists?
No, it's not static. So that's actually one of the, I think, points of consternation I've had about using this framework. One thing that we have is recently we added a strict mode, right, which will warn you if you have, queried a DSL item, like if I accidentally wrote like, delete or something, right? That's quite hard to check, to identify. So, let's say I wrote delete instead of delete button, right? Yeah, here. So if I did something like that, yes, it would silently do nothing by default. And that's sort of, not ideal when you're testing. So we have a strict mode that will warn you if you've made like a DSL typo. But the right way to address this, of course, is with an LSP of some sort that would integrate and, maybe check some of your DSL names at compile time or before.
Thank you.
Mm-hmm.
I have a question from the YouTube chat.
Okay, hi YouTube.
What is the state of animation for Makepad and Robius?
Oh, sure, yeah. I mean, we have lots of different animations. I don't actually use too many of them in Robrix, but one example is here. If I can find my own message, let me clear out some of these so you can see better. I can, a very simple one would be the editing pane, which is not fully finished, but you can see I'm able to slide stuff up and move things over. Another example would be the profile thing here, right? So you can animate things in and out like that. We have a variety of other examples in the Makepad, like the more visually impressive Makepad apps that, this is a chat client, so there's not a lot of that. But yes, absolutely. We have, arbitrary support for animations and a variety of different, decay models and timing models and things like that.
Okay, if we have no more questions. Oh. One more.
Is there any plan to support accessibility?
Yeah, yes. So I'm not able to show off any of that today. We as a community have kind of rallied around AccessKit, a great piece of work by Matt Campbell. Yeah, okay. So we will eventually add support for that into Makepad itself. I'm not really an expert UI developer, despite maybe what you've seen today. I'm really not the right person to do this stuff, but the idea is to emit a UI tree, much like the widget tree that you saw earlier, that can be then connected to AccessKit in order to have that connect to the rest of the platform-specific accessibility APIs.
Amazing, thanks.
Yeah, but I will say it's probably going to be a while, unless, of course, I can have undue influence on the Makepad team to prioritize that, which I will try.
Thank you very much for everybody who came to the talk, and thank you, Kevin, for the fantastic.
Thanks for listening. Appreciate it.